Welcome back. This is the second lesson video for day 5. Where we left off was a plus bi. That's the standard form of the complex number. So we can use the values that we found here. A can be replaced with r of sine of theta. So here I can replace that with r times sine of theta. And b can be replaced with r times cosine of theta. And to that, we need to bring down the addition, and we need to bring down the I, and this simplifies to R multiplied by sine of theta plus cosine of theta times I times cosine of theta. And this is my polar form. Okay, this is my polar form of the complex number. Okay, so of complex number. So let's bring that back to our original example. So 3 plus 4i. 3 plus 4i is represented by the same point there. Okay, so, but what this is saying is that this point right there, the radius from the origin is, we found the radius to be 5. So in this case, we know this radius is 5. And the angle measure here is going to be 53.1 degrees. So this point can be represented as 5 parenthesis sine of 53.1 degrees plus I times sine of 53.1 degrees in parentheses. So that will be the polar form of the same point, same complex number right there. Next, we're going to try to plot the complex numbers on a polar plane. So we have 4 different points, A, B, C, D. The first thing you should notice is that when I have 3 parentheses cosine of pi over 2 plus I sine of pi over 2, you should be thinking about, oh, I have an I here. Maybe this is a complex number represented in polar form, and it does follow the pattern, doesn't it? Okay, R is the number in front, so that this tells me the radius is 3, and sine of theta. Okay, you know what? I just realized my big mistake. This is not correct. This should be cosine of theta plus I sine of theta. Sorry about that. And the mistake goes all the way to the back. This is not A. This is A should be this value. Okay, so this should be A value here. And this should be B value here. A is equal to 3 and B is equal to 4. So that means this is going to be B over A. So B is that, and cosine of theta is going to be A over R. So A is equal to R times cosine of theta. So this is going to be changed to sine and cosine. I am so sorry. At least I found it. Okay, did not quite look right. Cosine of theta here and R sine of theta. So this is going to be cosine of theta, R multiplied by cosine of theta plus I times sine of theta. Okay, so now that is in the same form as this. Alright, so here we are dealing with complex numbers represented in polar plane. So we have the radius of 3, but the angle measure is pi over 2. Okay, so first thing you should notice is that we are no longer dealing with real and real axis, or this, the horizontal axis is real axis, but this is my imaginary axis. Okay, but as far as the angles go, it is still the same thing. We still have 0 degrees or 0 radians all the way to pi over 2 and all the way to pi and 3 pi over 2. Okay, all right, so now we're dealing with pi over 2. Where is my pi over 2? Pi over 2 is right here, and so the angle is pi over 2 and the radius is 3. So my point A is going to be right 1, 2, 3, 8 right there. Point B, radius is -2, angle is 30 degrees. Where is my 30 degrees? My 30 degrees, 15, 30, so this is my 30 degrees. So we are along this ray, but the radius is negative, so we have to go the opposite direction by 1, 2. This is my point B. Okay, and then point C is angle measure is -pi. -pi, negative angle means we're going this direction, measuring in this direction. And pi is half a circle, so we are along this. So positive pi and negative pi, they're actually the same thing, isn't it? Okay, and the radius is 1.5, so this is 1.5 right there. So that's going to be my point C. And finally, point D is -70 degrees. -70 degrees, 15, 30, 45, 60, 70 degrees. This is 75. 70 degrees will be somewhere along here. -70 degrees. And we have the radius of -1. -1 means we have to go the opposite direction, and it is going to be right there. This is my point D. Okay. Now we're going to try converting from polar form to standard form. So we have 4 points in polar form. Can we convert those to standard form? Well, let's just start with one of them. A, we are dealing with 3 multiplied by cosine of pi over 2 plus I of sine of pi over 2. And you just need to evaluate, okay? What is cosine of pi over 2? Cosine of pi over 2, go to your unit circle. Pi over 2 is my quadrantal, right? Cosine is my x value. Cosine is x value is 0. So it's going to be 3 multiplied by 0 plus I times sine of pi over 2 is 1. So that's just going to be 3 times 0 is 0. So that's going to be, we don't have any real portion, but we just have 3i. And that's exactly what we're dealing with. 3i, we don't have any real portion, we just have an imaginary number of 3i. Alright, let's try B. Okay, let's try B this time. B is -2 times cosine of 30 degrees plus I of sine of 30 degrees. Okay, so this is same as -2 times, what's cosine of 30 degrees? Cosine of 30 degrees is √3 over 2. Go to your unit circle. Okay, plus I multiplied by sine of 30 degrees. That's my easy 1/2 that I asked you to memorize. Sine of 30 degrees is 1/2. Sine of 30 degrees is 1/2. So then multiplying -2 to each of them, that leaves me with -√3 plus I times -I. So it's going to be negative or minus I. So B, equivalent form of B is -3 plus I. So if I was to find the coordinate of this rectangular coordinate on the complex plane, it's going to be -3 on the x position, and the y position will be -1 here. Okay, and you can do the same thing with the as well, but I am not going to do that. Okay, now we're going to try to convert from standard form to polar form. If you look back earlier, what we did from here is if I have a generic form of a complex number, standard form a plus bi, then from here you could calculate what r is and also the theta. Or I summarized it right here. If I have a plus bi, I know that a represents the horizontal distance, b represents the vertical distance, right? So I know that to calculate the radius, r is going to be square root of a squared plus b squared. To calculate the angle theta, that comes from the fact that tangent of theta is b over a, opposite over adjacent. So that follows that theta, to find the theta value, is going to be inverse of tangent of b over a. Something to note is that you must draw a sketch of the complex number graph to make sure the angle is correct. This is the most common mistake that students make, is not getting the wrong quadrant measurements. Okay, so make sure you do that. To demonstrate that, we're going to try this example. -4 minus 4i. Okay, so if I was to plot this, -4 plus minus 4i, -4 is going, let's just call that, this is going to be -4. And then -4i, let's just call that -4i. So this is going to be my point, -4 minus 4i. Okay, so then from here, how do I figure out the radius? Radius is going to be, okay, radius is going to be distance right there, which is given by square root of a squared, that's, and what is a? A plus bi, so a is -4 whole squared, plus b is also -4, and that's 16 plus 16, that's 32, square root of 32, which is same as square root of 16 times 2, or 4 root 2. All right, so then what about theta? Theta is going to be given by inverse tangent of b over a. B is so theta is going to be inverse tangent of b is -4 over -4, which is same as +1. And if I use the calculator or use your unit circle, what is the angle measure that gives tangent of 1? That's going to be 45 degrees. So if I use the calculator, it's going to give me 45 degrees, or pi over 4. However, are we dealing with first quadrant? You see, tangent is defined, inverse tangent is defined for quadrant 1 and quadrant 4 only. And that it's always going to give you a quadrant 1 or quadrant 4 value. It's not going to give you quadrant 3 value, which is what we need, right? So in order to do that, we know that what the calculator gave me is this angle right there. So what I need to do is add 180 degrees to this, and so that the actual theta is going to be 180 plus 45 degrees, so that's 225 degrees. So I needed to add 180 degrees to it. Okay, so now that I know what radius is and what theta is, I can say that the polar form of this complex number is 4 root 2 multiplied by cosine of 225 degrees plus I sine of 225 degrees. And that's my final answer. Okay, now I would like you to try to practice it yourself. Okay, so if I give you -4 plus 5i complex number in this width of -4 plus 5i, can you convert this into a polar form? And I want you to give the angle measure in radians. Okay, here we gave the angle measure in degrees, so I want you to do it in radians.